So two main goals today. This is going to be pretty easy, pretty fun. First, we're going to cover something that we didn't get to do last week, and that is to start telnet on a router. We're going to telnet into it from another router, so that should clear some cobwebs up for some CCNA folks, I think. And then we're going to sniff the traffic to show you how vulnerable telnet is. So everyone says telnet's bad, you should never use telnet, but they never actually show you why that is the case. So you're going to see today why you should never use telnet on a serious network. Now, inside GNS3, it's fine. No one's going to hit that, but once you start getting into an enterprise, it's bad news. Then we're going to do something really cool is we're going to play detective with Wireshark. You're going to have a trace file. The link I gave you before, also the link is down here. You just download that trace file into your computer. We'll open it up and basically we're pretending that we are a network forensics guy at whatever big company, and someone's basically a disgruntled employee. He's been surfing sites at work and downloading stuff, and you've been hired, or your job is to find out what sites he's been surfing, the IP address of his computer, see if you can get the files, stuff like that. And we'll go over all the filters that you're going to need. Well, not all the filters, but most of the filters, and just some tips on making timelines and how to start an investigation like that. And of course our disclaimers, everything's being recorded, and the legal one, opinions here are my own and not that of my employer. Okay, certification announcements since our last week. So from last Wednesday, anyone with any recent passes on certs, Cisco or otherwise, doesn't have to be Cisco. And anyone with a new job that they can talk about. Oh, cool. Jeff says he went to Narbix boot camp. Which city was that? Oh, nice. New Jersey. So Raval, on everyone's icon that I look at in Fuse, well, almost everyone, except Oscar and yours, I see a microphone icon. It's crossed out because I muted everyone. So since I'm not seeing a microphone by your name, I'm guessing the problem is probably with your Fuse and maybe how it's detecting your audio. So Lewis says no new job, but one interview and have another interview on Friday. Cool. Interviews are good. It means that you've gotten past that first step of the HR drone. Cool. Very good. All right, here we go. Let's see here. Let's play detective. Where's our telnet? Our telnet's missing here. Okay, well, we'll fix that. Okay, so everyone start up your GNS3 if you haven't done so already. Two routers, R1, R2, real simple, really easy. And connect them up. Right, this you should already know how to do from our last 3 meetings. And then after you start them, you're going to start Wireshark capture by right-clicking on the link and click on Start Capturing. You're going to give you'll be given an option either R1 or R2. Doesn't really matter. You're capturing on the whole link anyways. Click OK. And then right-click on the link again and start Wireshark. So the first one is Start Capturing, and the second one is actually to fire up Wireshark. We'll click that guy. And of course nothing's showing up yet because the interfaces are down. Right? So we'll bring up our two console windows for R1 and R2. Pretty simple stuff so far. Maybe I should rearrange this in some fashion so you can see the live Wireshark along with the console windows as it happens. There you go, something like that. Okay, on R1, conf-t, we're just going to set an IP address on the fast Ethernet interface. IP address, all ones, and no shut. Right? And as you know, you've seen from the previous weeks, as soon as you no shut that guy, you're going to see CDP, you're going to see the keep alives, you're going to see some stuff happening there, and that's normal, completely normal. You're going to go over to R2, interface fast00. This is the other side of the link, IP address 1112/24, no shut. And of course, you're going to see more stuff in Wireshark, and the MAC address is slightly different. So it should be C200 for the first MAC address and C201 for the second MAC address. All right, let's change that. Let's change the MAC address on router. Let's go router 2 here. Staying on the interface, MAC address, or MAC dash address, AB, BB, 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 BB. Whoops. How about a whole bunch of A's and then a B at the end? There we go. We'll keep R1 the same. And the reason we're doing this is because C200 and C201 is a little bit too close to be looking at if you're looking at a lot of frames passing by. So if you see something starting with all A's, then you'll know it's router 2. If you see something starting with C2, you know it's router 1. Okay, so far everything we've covered, we've done this already. Now we're going to start telnet on router 2. Okay, so we want router 1 to be able to telnet into router 2. Now if you try to telnet right now without setting anything up, so if we telnet on R1 111.2, as soon as we hit enter, you're going to see some stuff happen in Wireshark. And it says on router 1, password required but none set. So that means that telnet is on, but it's just not configured correctly. You just need to do a little bit more to get this to go. Right? If we look at over here on Wireshark, we see we have a whole bunch of things from 1111 to 1112, 1112 to 1111, and it kind of goes back and forth. We have some in different colors, right? And if we expand this out, let's see what we got here. We got SYN, SYN-ACK, and ACK. Going to high port to port 23, port 23 to high port, and high port back to port 23. So from router 1 to router 2, router 2 to router 1, router 1 to router 2. Who remembers what this thing was called? The SYN, SYN-ACK, and ACK. It's the handshake, yeah, TCP handshake. Three-way handshake, TCP handshake, yep. All right, so, the CCNA level test, they love to hit you sometimes on this. They might give you a question or two talking about this, and they may flip these numbers around to trip you up. They'll say which TCP handshake looks kind of, is valid or is not valid. And, everything will look good. Maybe the IP addresses look good. They're going back and forth. It says TCP. But, on this first one right here, they might flip it and say 23 to 46, 565. Just something to look out for. After they've done the handshake, now they start sending data. Some data, some data, some data. And then right here you see FIN, fin. Well, if you know French, I'm guessing maybe it comes from France, I don't know. But basically, router 2 is saying, well, I don't really want to talk to you anymore. Our connection is done. And then after all that TCP stuff, we go back to our normal keep alives and CDP, right? So we had over a course of 146 on my screen to 148. So it took about 2 seconds, 2.2 seconds, or let's see here. Yeah, about 2.2 seconds that all this happened. Right? Was everyone able to see this handshake, then telnet, and then the teardown of the session? So this is completely normal. This is what you expect to see if telnet doesn't have a password set up. Now let's see what happens if we go up to this filter. If we type in telnet, it is a valid filter. It turns it green. If we hit enter, you're going to see the telnet and just the ones with data. Right? So this is a quick and easy way of finding telnet stuff, but you'll notice that if we go back to killing that filter, that it did not capture. When you filter out telnet, you're not going to get the TCP handshake. All right. So if you were in the court of law, what you want to prove, if you just show this telnet data, if the defense counsel is on the ball, or if they've got good consultants and stuff like that, they'll say, well, that data could be injected. He didn't actually request that. So that's why you have to include TCP, SYN, SYN-ACK, ACK. Just something to keep in mind. So you would want to be looking at this entire conversation and not just the telnet specific data, and that's what you get by typing in telnet. All right. Of course, if you just want TCP, in the filter section, just type in TCP. And it'll filter out all that other crapola, all that CDP and keep alives and stuff like that. All right. Now this data right here, let's take a look at what this data is. So pick the data packet coming from router 2, the first one, 1112, going back to 1111. So from router 2 to router 1. And let's take a look at the contents in there. You can see it says frame number, whatever. We've got a MAC address, right? That all A's, so we know it's router 2. Destination, C2, whatever, that's router 1. We've got our IP addresses. Now remember this, when you're at the top, you're at the bottom of the protocol stack, or the OSI layer. Then you go to layer 2, layer 3, layer 4, and so on. Right? Each one of these corresponds to a layer. If we open up the transmission control protocol, if we expand that out, you could see that it's coming from port 23 going to that port. Whoa. From port 23 going to that high port. Your port will be different, probably. Sequence length and all that good stuff. As we look down here, let's take a look at anything interesting here. Who has seen this checksum before? TCP checksum. Anyone know what that is? Or can you guess what that is? You've probably seen, let's see if we see Ethernet here. Error correction, yep. Things get garbled up. We can compare it to the checksum, and it will tell us if it's a valid packet or not. It's not too difficult to fake the checksum. If you wanted to craft your own packets. Okay, now what we're really interested in is down here under telnet. Let's see what, if we expand out all these things here. Oh, I clicked on the wrong one. There we go. Oh, and also remember to, if you have any filters that are lingering in your filter bar, remember to clear it out. Make sure it's just set on TCP right now. So you're only looking at TCP packets. Okay. So this first one, 1112 to 1111, if you expand out the telnet packet, you've got kind of this first command plane or control plane type information that says, okay, here's the different options we want in telnet. This is how we're going to do like like window size, terminal type, all that stuff. So we're setting the groundwork for future communication. If we take a look down on the second frame that came across, 1112, so first frame set up like the ground rules on talking. Second one, we have some data here. Look at that. It's carriage return, password required, but none is set. That was the exact text that we saw coming from R2. So if you look at here, oh, this is what we got here. Password required, but none set. And if you look here, this /r/n, it's basically a carriage return. If you look back at your terminal screen on R1, there was two lines here. So that's where the two lines come from. And then this one down here, that added another line. And that's this line over here. Right? So the exact text that you see on your screen flew over the wire. All right. Okay, so that's cool, but not that interesting because we can't actually telnet from one machine to the other. So we need to go on R2 and set this up. Just as a quick survey, who has never set up telnet before? Ever? It's easy, but just want to see if anyone's like not done it before. Okay, oh, should be easy. On R2, we're going to go into what's called the line VTY lines. So line VTY. And typically you would do something like 0 to 4, but if you have a question, different models have different line numbers. 0 to 4 will work. right? Now you could do a whole bunch of commands here. You just question mark and it will tell you all these things that you could set on these telnet lines. Right? But basically we could type in password and then some password, right? Cisco. There are many ways of configuring telnet and SSH authentication. You can have the password on the line. You could have a username and password. You could check it off to radius if you wanted to. There's a whole bunch of ways you could do this. And in CCNA, you get a little taste of it. You know, the whole secret password, enable password, all that stuff. But if you want to get really crazy and all the crazy AAA stuff, then you want to start looking into CCNA security. Okay, password Cisco. And so now if we go back to R1 and we telnet 1112, let's see what happens. And our Wireshark's still going. Let me just scroll down to the bottom there. We're still in live view, I think. Okay, we got a password prompt. We got a surge of activity that just happened. Let's type in a password. And we are in. Right? So we're in, we know that because we see R2 there in our prompt. If we go on R1, if we type in show line, it should show that someone is connected. Who's ever done that trick of sending text messages to the other people on the lines while they're logged into the router? Yeah, there's a way. So if you have a whole bunch of people telnetted or connected to the router, any one of them can send text messages. It's kind of like I don't know if you guys remember on Windows, there's this command called net send. So net send you would send to other computers on the same Windows NetBIOS network. In Cisco, you could do the same thing. I just have to remember how I did it. I scared the hell out of the guy because the message I sent was router will shut down in 5 seconds. And the syntax is a bit weird on that one. Send. That's simple enough. Send star. There we go. So send star, you type in your message, Control Z to end it, and then on R1 you saw this pop up. So just a stupid trick to scare the new CCNA hire. There you go. Please don't do this on a DoD router or something like that. That would probably be bad. Okay, so enough fun with that. So we were able to log in with Telnet. Everything's good. Let's take a look at how Wireshark sees that. We'll type in Telnet. So we're only concerned about the Telnet data here. So you see all these that have, we have a lot of Telnet packets here, right? Where do we start? Well, one thing is look at the times, right? Our first time we were at, on my screen, 146 seconds. And by the second time we started doing our telnet, after we set up the password and everything, I'm at 931 seconds. So we have the big gap in between here. Right. So that's kind of one way of kind of looking at, okay, when was our first time and when was our second time? That kind of divides everything up. Also look at the length of the telnet. So a lot of times you'll see 60, and 60 is like, okay, whatever. They're negotiating the different things in there. 60, still negotiating. But then when you get to the ones that are larger than 60, significantly larger than 60, so right here I've got one that says that has 91 bytes. So we've got some juicy data in here. And we've got this here at 96, same deal. And then we have this one at 165. This is when we were playing around the messages. Right, so you get to see everything. So be looking at the links there. Well, let's see if we can see that password as it flew over. We know that on my particular timeline, at 931 seconds, our second conversation started. So we know our first packet that goes across from router 1 to router 2, this is just setting up the conversation. Right, so that's not a big deal. Router 2 to router 1, same thing. We're both setting up our conversations. Okay, still setting up. Here is where router 2 is setting up the password prompt. It's like, all right, so what's your password? What password do you want to type in? Okay, down here, that looks like some diagnostic stuff. Now, eventually, we're going to get to, if you start clicking through, now this is the very manual way of finding out what he typed, and you're going to see something interesting here. Once you get to the one that has data equals C, that's the first C in your Cisco. If you hit the down arrow, assuming that there's no other TCP or telnet stuff happened in between, if you hit the down arrow, the next one's going to be I. Down arrow S. C O. Right? Well, that spells out Cisco. And then when you hit enter, what happened? Enter is the Wireshark sees it as /r/n carriage return. And that completes the password over to R2. So notice how everything was one Cisco, right? Now here's something for the Cisco trivia fans out there. What's that command or that service that is breaking this telnet text out into one character per telnet packet? What's doing that? I mean, why not, if I type in Cisco, why not just shoot all of Cisco across? So this is something that some CCI guys will remember, or will at least be familiar with. So do a Control-Shift-X on router 1. That will get you out of the telnet session, or you can end it. Let's see. Go into conft and type in service and question mark. service nagel. Don't worry if you've never played with this command before, but most people haven't. This is one of these things they like throwing at you in CCIE. So there's service nagel. Let's see if I show run pipe I nagel. There we go. And then of course you could turn it off. No service nagel. So it looks like no service nagel disabled is by default. So let's see if that actually does anything here. If we go to the command reference, let's see here. There we go. Basic system commands. Service nagel. I'll shoot the link into your chat window. Okay, TCP congestion stuff when you're sending keystrokes between machines. Right. So basically what's happening here is, do you want to send each keystroke as its own packet, or do you want to hold the characters until, whatever, some time, and then just shoot a batch through? All right, so let's test this. Let's do service nagel and see if it does anything at all. We'll telnet to 1112. And you can keep the filter for telnet on Wireshark. Telnet 1112, hit enter. We'll type in our password, Cisco, and let's see what we got over here on Wireshark. Once again, filtering through all these telnet, we're going to look for one with a time gap. So we had approximately 160 seconds of time, so it's like a minute and a half. Right? We know our first couple are just setting up the negotiation, nothing too bad. We know it's around 60 something. We know that 96 is the asking for the password. See, start noticing the patterns here. And then let's see if we start seeing Cisco somewhere. Oh, didn't look like it did that much. Let's see here. CISCO. Yep, still did the same thing. Just for kicks. All right, let's try both with service nagel and then without service nagel. Yeah, it doesn't seem to do anything. /177 is a backspace. Let's see. That it is. Yeah, for those guys used to like hex editors and ASCII codes and all that good stuff, a lot of stuff you'll see in Wireshark will make you feel right at home. All right, so you can see right here, clear as day, that you can see the password. Now, what are some easier ways of filtering this out? Well, here we now have a trace that's getting up to a couple thousand frames, and this can be, it's 500, but let's assume you have like 500,000, frames that you've captured. So it's like, where do you start? Well, telnet would be the obvious place, but here you're seeing a lot of telnet. You might have to fish through quite a bit, right? So there's a couple ways to look for this. Well, we already know that telnet asks for a password as part of the handshake. So if we go back here, just before you type in the password, it gives you that prompt. So password required but not set, that was when, so like here, it asks for password, capital P, and then with the colon at the end. So what you could do is you could cheat here. Let's see if this works. You could type in frame contains question mark and the word password. And we hit enter, and we get all the ones that have that word. Now, of course, you're not interested in looking at this particular frame. What you would be doing is going, okay, well, I'm looking at this frame. The frame that comes right after would be the one I'm interested in. So what you could do here, let's see if this works. You can right-click that frame, follow TCP stream, and right there, that is the password right there. Got password. I got some extra stuff, but you've got the echo command here, so some things are doubled up. All right, so what we did there was we said, let's clear this out. We'll do it again. Frame contains, and here we're looking for text, any text. Yep, and someone pointed out case sensitive, yeah, so capital P shows up just fine. Lowercase p does not. Let's see if it'll take a wildcard. Oh. There's a different syntax that will take wildcards. Frame contains capital P password, and it'll filter everything out. And then you just right-click, follow TCP stream, and you're going to get the data right there. And you could save it, print it out, whatever you want. All right. Countermeasures against this, well, don't use telnet. That would be one way. That would probably be the best way of fighting against any eavesdropper that's sniffing your telnet stuff. But you can see right here, telnet, along with any other plain text authentication method, is just bad if the guy knows what he's doing with Wireshark. A 5-minute course in Wireshark and you could sniff any type of plain text authentication out there. Right. Was everyone able to fire up telnet on one of the routers, telnet in, and see the information, see the passwords with Wireshark? Any problems with that? And for the guys who've never looked at the telnet authentication and actually seen the password before, does this seem easier or harder than what you thought it would have been? Okay, so the filter I used for seeing the password, here's what I did. So I did frame contains, do a quote, and then the word password. Now, this password, I'm not actually telling it, give me the frame that has the password. I'm telling it, give me the frame where the router asked for the password. So that was your login prompt right here on R1. Right there, where R2's asking you, okay, type in your password. That's what it sent. And the reason for that is I want to get the list of packets that are part of a conversation. And I want to carve out the conversation. So then after that, I right click on it, and then I'm going to follow TCP stream. So I'm basically ripping the 5 packets out of Wireshark, or however, 5, 6 packets out of Wireshark, and it's going to throw them back together, take this Lego blocks and put them all back together and give you the output. And if we compare, that's pretty good. This extra stuff is just there. There's other stuff happening in the background that you don't see. One thing I do sometimes at Wi-Fi cafes and Starbucks and stuff like that, if I think that someone is sniffing the network, I log into some weird ass sites beforehand that have username and password prompts, and I just start typing in fake stuff. I'll go to like 5 websites, type in 5 fake things. They'll all bomb out, but it's just to add some extra noise to what he's looking at. I also have a ostinato script that I'll fire over the Wi-Fi that just has a whole bunch of fake username password authentication. It's like, okay, chew on this. Have fun with that. Okay, so that was quick and dirty looking at telnet. That's why you should never ever use telnet. And if anyone asks you why or how, then now you can demonstrate to them, well, let me show you how easy this is. Okay, you could close this up. We are done with GNS3. Open up that Wireshark trace that I sent you guys. And you can stop and quit without saving on Wireshark. And you could close this out. So find that trace file. And you should be able to just double click on it. And boom. Not too bad. It's about, 1,700 something packets. Which is definitely on the low side. If you were actually looking at a real case, you would be dealing with hundreds of thousands or millions of packets. Yeah, it's in the HackPad link. I'll paste it in the chat window. Okay, and when you have the trace file loaded up, you should see like greens and grays and stuff like that. Just click the flag icon on your Fuse meeting next to your name. So just click that flag icon. That way I know that people are ready with this. Right, so just double click that PCAP file. Should automatically open up Wireshark. Okay, so we're assuming that we're dealing here with a disgruntled employee. Just hates his job. You can assume he's either corporate or government employee. Who knows? Maybe he was in Hawaii. Doesn't particularly like the situation. He wants out. And we've got this trace file, and we can basically say it was basically captured at his computer. So whatever his computer is, we were able to get on it and capture for about 5-10 minutes or so. So we want to figure a couple things out. What's his IP address? His home router or his gateway, I should have said gateway IP address. gateway IP address. Bonus points if you can figure out like what brand is this home router. What websites did he go to? What applications are installed on the computer? So pretty basic stuff, right? And of course, at the end, we want to see if we can retrieve any files that he grabbed. So we're going to pretend to be a detective. We're building a case against this guy. So in doing this, you first want to get a sense of what you're dealing with, or how big is this problem that you're dealing with. Okay, so we have 1,700 packets. We have a time. Time will always start at 0. And if we go down here, click this icon at the top, go to last packet. And if you go to last packet, 66 seconds. So this is like a little over a minute, right? So it's not too bad. 1,700 packets over a little over a minute, that's actually pretty quiet. Okay. And you just kind of, if you want to scroll through it, if you're dealing with a minute of traffic, okay, fine, right? Another thing you want to do is you want to get the low-hanging fruit first. You want to get a sense of, okay, how many DNS requests were happening at that time. So always the first filter I do when doing any of this stuff is DNS. That's the first filter I do. And we see like this guy likes Reddit. There's other stuff too. There's Twitter came in there. You're going to see a lot of Akamai for the CDN. Of course, we got some Facebook, some Google, right? Now, just because you see so much DNS in here, we've got let's see here, displayed 56 displayed, doesn't mean that this guy visited 56 web pages. We need to figure out what web pages he manually went to versus what web pages or what DNS entries were called up from the web page. So as you notice, when you go on ESPN or basically any big page these days, ads come up, just tons of crap pop-ups, lots of stuff comes up. Each one of those is also spawning a DNS request. So if you just say, if you go in the court and say, well, over this 1 minute, this guy went, if you didn't know what you were doing, you're like a brand new forensic guy, and you're on, you're being interviewed by the defense counsel. Yes, over 66 seconds, this guy went to 56 websites because I see 56 DNS requests here. They're just going to laugh at you at that point. You will just get roasted alive. So how can you tell? How do you know which ones are real? You typed it in, the user typed it in versus the computer. Well, if you look at the timeline, the time column here, you'll see that, okay, 1.5, 1.5, those came fairly close together. One's a query response. So you could filter this down by the query instead of just looking at all DNS. So when you filtered by DNS, you basically got your computer asking and then the DNS server telling you back the answer. Right? So in essence, we're right off the bat, we're double counting. Right? So to further filter this out, let's see what we could do. If we type in a dot after the DNS filter, we got tons of crap. Right? So let's see. We got query class, query name. We got some responses. Let's do DNS response name. And hit enter. So this is the response coming back, basically saying, okay, you wanted this. Here's the information you wanted. So right now that 56 went to 28, cut in half. That should make sense, right? But still, you stand up in the court of law, you say, okay, this guy visited 28 websites, or he asked for 28 websites in 66 seconds. You'll still get laughed out of court. So looking at this timeline, you'll see that the first, right here at the 2-second mark, we've got this group of 1, 2, 3, 4, 5, about 7 or so. You can't visit 7 websites in less than a third of a second. So it should be obvious that the web page called this up. At the 3-second mark, we have kind of the same thing. 12-second mark. At the 52-second mark, we have another flurry. He went to another website. And then at the 65-second mark, he went to another website. So we're looking at about 5 to 6 websites, right? And you would say, okay, at this time, he went on this website. At this time, he went on this website. Now this is a relative time from when the capture was first done. We need to probably add a column that will tell us the real time, either UTC, local time, just 8 p.m., something like that, just to make things a little bit easier. So we'll right-click on the column, and we'll go to Column Preferences. So the way you do this is you're going to right-click on the top here where these columns start. Right-click, Column Preferences. These are your list of columns. We're going to add one. And the title will be, let's call this Real Time. Click the drop down, and you could pick, UTC is fine. And then click OK. Now it's going to add it probably to the back here, and you can simply drag this across. There we go. And now I've got a column for UTC time. And it's down to like the freaking micro nanosecond, some crazy precision there. Right. Was everyone able to get UTC time to show up in their new column? So now I got relative time compared to the first capture packet, and then we've got UTC time. So now we could say, okay, at 3 minutes, 41 seconds, he did this. And then at 4 minutes, 10 seconds, he did this. Now, if you present this data the way it looks like in court, the jury, you're going to lose the jury, right? The lawyers will hate this. They like those big, nice timelines, nice looking timelines. You could throw all of this in Excel if you wanted to. You can manually make a timeline, which would just be, you would give it to the intern. I wouldn't expect a normal person to make this timeline. But you can use a commercial service. One service that I like is called Time Glider. Time Glider. They have free and paid accounts. We're not sponsored by them, but it's something I've used before. I've pasted the link in the chat window. This lets you make timelines, basically. And you can zoom in or out just using the cursor key or the scroll wheel on your mouse. You can do some pretty awesome stuff. You could double click on the timeline to make a new event. So let's say started surfing something. Now the precision is it's meant for calendar items, so it's not really meant for sub-minute type things, but you kind of get the picture here. You can zoom in. You can edit things. It's pretty nice, and then you could print this out. And I think the paid version is pretty slick. You get a lot more options there. This isn't the only one. There's many other timeline creation tools out there that you could use to do this. But basically, you want to make something pretty. Is that you could use like a laser pointer or a stick and say, okay, at this time he conclusively did this, and you would have a a screenshot or whatever that popped up. Okay, so DNS response name, or looking at the queries. Okay, now if we scroll to the right, you'll see that there is the info box. And in the info box, if we expand this out a bit, you could see that everything comes after, the interesting stuff comes after the CNAME. That's what's telling you the actual website that he's going to. Right? So if we look over, let's see what's going on here. So let's see what we got here. VOA, Boston Globe. There was some. The first site was probably Reddit. So whenever you go to Reddit, just a whole bunch of crapola is going to come up. Some Twitter. Then he went to RAND. RAND is a think tank that publishes reports and stuff like that, right? So now what we could do is, we remember from before that we were able to type in frame contains and then a question mark. If we weren't sure that he went to Reddit, we could just quickly go frame contains quotes Reddit close quote. And right there, query for www.reddit.com. Can TimeGlider import from Wireshark? No, it cannot. Not natively. Let's see here. Let's see what the premium account gets me here. They just want my credit card info. Okay, here we go. So we have the free version. We got the $5 per month. Let's see what we could do differently here. Collaboration, any importing, batch editing might be something like that. Okay, so we're coming up on 70 minutes. No problem. Okay, so he likes Reddit, which could be good or could be bad. We know that he likes RAND, which is interesting. Oh, that was bad. That was a lot. Now, you notice that when I typed in frame contains RAND, it gave me like a whole bunch of crap, right? So that shows me basically when he went there, all the pictures came up, the JavaScript, it's calling out the whole web page. Right? So that's part of the DNS. That's why you can get so much with DNS, and that's always why I do that first. Right? Then I look for telnet, SSH. You can simply type these in the filter bar. Telnet, SSH, HTTP. You're going to get a lot here. On Windows, and if you have a Synology box, you're going to get this SSDP. This is like a multicast share finder thing that also runs on port 80. So that's why when you type in HTTP, that shows up. Type in TCP, you're going to filter out TCP. UDP is useful sometimes, but you're going to get a ton of UDP. A lot of stuff falls under UDP, including DNS. And then POP and SMTP. Although these days, POP and SMTP aren't going to show up too much if the guy's using encrypted email. So a lot of the email service providers out there have switched to force SSL only. So I had a little hand in doing that, in forcing Google to go SSL only. And I don't know if it's still up. No, we don't want to do that. So there was this thing I demonstrated on Fox News National of sniffing cookies from Gmail and then becoming that user and sending out like a fake email and stuff like that. It was actually really easy to do at the time, but it was because once you got the cookie and Google didn't force you to be SSL. Can't do it now. Okay, so filtering common protocols, that's just the easy, hit the easy stuff first, right? You also want to get a sense for how much SSL is there. Now, why is that important? Normally, you won't be able to view anything inside SSL because it's encrypted. But if by chance you get a private key later from someone, then you can enter in the SSL key, the private key, and this will be able to be viewed. Now, if you look at this normally, it's not gonna be that interesting. It's just gonna be gobbledygook because it's encrypted. Okay, drilling down into the data. We already know about the whole frame contains. I seem to like that quite a bit. You can also do finding by going to edit and find packet. That's another way of doing this. I'm going to click here, find by string, and let's see if it will find Reddit there. Find by string, packet deals, Neville wide. Let's see. Yep. Doesn't exactly work very well, so I like frame contains. Just easier to type, less going by the mouse and going up here to edit and find. If you just want to filter out stuff that contains data, very easy. Data in the filter. You're going to get a lot, and you'll have to carve out stuff. If you want to see if he grabbed any PDFs, maybe he grabbed some interesting documents. I always look for PDFs because those are easy to reconstitute. Frame contains PDF. And so 10.04.15, that was kind of near the end of his talk. Oh, this column right here, I added this. This is the DNS name. Very useful. So you know that he was on ran.org while he got this. His IP address, well, we want to know his IP address. It's 192.168.0.8. And look at that. If we scroll over all the way to the right, man, it just keeps going and going and going. And it looks like he looked up something for catastrophic risk, homeowner, community, something, 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 right? And then afterwards, you're going to see TCP segment of reassembled PDU. Right. So this was the GET request to actually get the document. And looks like we've got, yep, this is the actual name of the PDF, CT417. And then this is the actual guts of the PDF coming in. And so very simple, just like when we did the telnet password, we right-clicked, view TCP stream. Here, similar, just keep that clicked, go up to File and Export Objects. So File, Export Objects, HTTP. And let's see if we can grab this this PDF that he downloaded. It takes a while depending on the speed of your machine. And you can see ordered in packet number. Got RAND here. We got all this stuff. Now what's going to happen here is it looks like you can click and save individual ones. It doesn't actually work that way. You can, but what I prefer to do is just save all. Save all because I like saving all and then having Windows preview the pictures, and then in one shot you could see everything that happens. So let's save this to the desktop here. Always a bad place to save. You can create a folder. Let's create a folder. Okay. So I saved it. Now I just have to find it. I called my folder Ganja Test. Now a lot of this stuff is like JavaScript, GIFs, not a big deal. Normal PDF stuff applies, or normal file viewing applies. You sort by size and look at the largest one. Okay, we've got PDF right there. We've got some PNGs. So if I double click this PDF file, that's the document he downloaded. He downloaded Catastrophic Risk in California. This has to deal with earthquake and, you know, how much money people would have to pay out if a big earthquake hit California, that type of stuff. Okay, how many people were able to get the PDF out of the trace? Okay, not a problem. Very easy to do. So what happens here, just a quick 30-second recap. This was all your packets. That was everything. All we did is filter it down, frame contains, and then the word PDF. So there's a quote around that. Hit enter, and these are all the frames that have the word PDF. Right here with the HTTP protocol, this was the guy asking for it. And then below that is the data, the actual data part that comes back. So we know that there's a PDF in here. Now if you go to File, Export Objects, HTTP, it's going to rip through the HTTP protocols and reconstruct all of that stuff. Now if you're eagle-eyed, you saw SMB, SMB2. Windows stuff. So, but we'll do that later. So HTTP, you're given all these objects and then just save them into a folder and double click that PDF file.